Good morning, everybody. Welcome, welcome, welcome to our final PODSCast of 2023. We're super excited for all of you guys to be here with us today, and we're stoked to get started. We're going to be talking about some ILI and data modeling and advanced analytics on PODS 702 with the new release of the ILI module. So super excited to get started. Today is November the 14th. It is 10 a.m. Central. And with that, we're going to get straight into our agenda and safety moment. So hi, my name is Monique Roberts. I'm the Executive Director here at the PODS Association. Super excited that you guys are all with us here today. Our quick safety moment, since it is the end of the year and the holidays are coming up, I just want to make sure that we are keeping in mind some fire safety in using your holiday lighting. So all of my friends love to make fun of me, but I put my Christmas tree up the day after Halloween. So my nieces and nephews always tell me to give the turkey a turn, Nikki. And I'm like, I'm not doing it. I'm going straight from Halloween to Christmas. I don't care. So anyway, just make sure that when you're putting up your lights and everything that you don't have any frayed strands or wires. If you're doing a live tree, make sure you keep watering your tree throughout the season, especially if you put it up, a whole month ahead of time before everybody else like me. So quick housekeeping on your control panel. You're going to have a lot of different ways that you can interact with us throughout the podcast today. So we're going to give you some polling questions. When those polls come up, try to put those in your primary monitor. If the poll box is in your secondary or tertiary monitor, sometimes it doesn't work very well. So when those pop up, if you can, move them into your primary monitor. And then also, if you have questions throughout, please put those into the questions box or the chat box. And then after the podcast is over, we are going to, it's going to pop up for a survey. So if you could, please give us some feedback. Let us know what you think about what was presented here today, and also give us some ideas for some future topics that you might be interested in. So with that, we're going to get into introducing Petrabytes and our awesome panel that we have today. They're going to talk about some current challenges in pipeline integrity. They are going to do a demo, a live demo, which, wow, I'm always impressed whenever people do live demos because that's awesome. That means your software really works. And then they're going to talk about some predictive analysis using the data model and some real-time sensing data. All of this goes back to utilizing the digital twin, which we're very passionate about here in the PODS Association. And just want to go real quick into the actual PODS Association and give you a quick overview. For those of you that don't know, these podcasts are open up to everybody, be it a PODS member or a future PODS member. There's only two categories, PODS member or future PODS member, right? PODS is celebrating their 25th anniversary this year. And it's just an absolutely incredible organization. We are made solely up of volunteers, and we do some incredible stuff together. And so all of these great minds get together and sit at the table and they innovate and build a path forward to that digital twin and asset knowledge management. We currently have over 200 pipeline operators in 38 countries. I need to update this slide. All over the world that represent over 3 million miles of pipeline assets and systems. So it's huge, right? We're growing and growing. We've topped now 130 active members of PODS, which is just absolutely incredible that we've grown to such a height before. So some of the benefits of the data model. So whereas, we really are a great community and an association of people that get together and put all of our best minds together to innovate, we do that through working together in the PODS model. The PODS model is, PODS stands for Pipeline Open Data Standard. It's an open, compatible platform with a multitude of different platforms and GIS platforms. We predominantly, of course, all of our members are all Esri users. Absolutely works with that. We just released PODS 703 utility network and APR, which is very, very exciting that we're integrating there with them. And also the PODS 7 data model now can integrate with UPM. So it's no longer all or nothing. You can integrate the PODS model into whichever database you are currently using and data model you're using. So it's a linear reference database. It's great for large diameter pipe that has to capture a lot of data and a lot of analytics around that data, and is regulated, right? Because there's a ton of regulation that surrounds, all of the data that needs to be captured for your pipeline, so that you can run an optimized and safe pipeline that is in compliance with the regulation. And speaking of that, our next PODSCast, which is going to be in January, is going to be with PHMSA, and they're going to be talking about all of the mandatory minimum variables and attributes that you're going to need to capture and submit with your MPMS upload. So we're going to stop talking so much about pods. We're super excited that you're here. We want us to tell you, we want you to tell us a little bit about yourself. So while our very good looking panel is going to be introducing themselves and telling us a little bit about themselves, we're going to ask you to tell us a little bit about you. So you should have a quick poll that's popped up into your screen. And if you could please let us know what your main job function is. We do this because we really want to find out who is in the audience. We have just a multitude of different people, from operators and service companies and software companies, and then within operators we have just a ton of different roles that are participating in these. And it's good for our panelists to know who all is participating, so that they can kind of morph their presentation to what's valuable and important to you. So let's see, with that we have 75% of you that have voted, so I'll close the poll and show those results. Sashi and Susan, what are the odds? What do you think? How many are you thinking? Oh, is that what you thought it was going to be?
Yeah, I thought there'll be more of integrity management, so yeah, more on the engineering and integrity management. So
yeah,
thank you. Yeah, I thought so too. But it's great to have, and it makes sense that people have like roles that kind of overlap. So they're probably having to figure out how to label themselves in this.
That's a great point, Susan, is that, nowadays, nobody has one job, right? Everybody does multiple jobs, and it really attests to that. And especially, I'm sure you'll agree with all of the clients that you speak with, is, it's all integrated, right? We're all there working towards a singular goal of pipeline safety. So if you could, guys, tell us a little bit about yourselves, please.
Well, I guess I'll jump in. I'm Susan Nash. I'm an advisory board member for Petrabytes. I'm also a director of Innovation, Emerging Science and Technology for AAPG. And one of the things that I think is a cool overlap is we talk a lot about sensors and methane monitoring and the new upcoming regulations. So it's these are exciting times and lots of opportunities.
Awesome.
And I'm Sashi Gunturu. I'm the founder and CEO of Petrabytes. So I've been in the energy industry for more than 23 years, building software solutions for Baker Hughes and then with Petrabytes. So we are providing solutions both for the upstream and also for the midstream, and more on the industrial AI, which we'll be talking a little bit more in detail.
Awesome. Well, guys, I really appreciate you guys spending time to be with us today and show us what you're working on. It's really rad. I got a little bit of a taste of it, and I think everybody's gonna really enjoy your presentation today. So, so that we get a little bit more information from the audience today, if you could, guys, everybody, please let us know what version of the PODS data model do you currently have deployed. So we only have a few of the options here. Of course, PODS has been around for 25 years, so there's many different versions and models. These are the ones that we think are the most predominantly used. So, for your service operators, for your service companies, if you want to let us know which of the PODS data model that you have most recently deployed, how about that? That would give us a good idea about maybe where people are and where people are going. So don't forget to just put that quick poll into your primary monitor so that you can give us some answers on those. And again, your service companies, please let us know which of these you're doing in the majority of the time. So, all right, Sashi, What do you think is going to be the most voted?
I would say a mix because most companies have proprietary workflows, so it will be a combination of pods and their own proprietary databases.
That's a good answer. Good answer. All right. Well, we are 65% voted, so I'll close the poll and share those results. And I'm very surprised at this, that people are still on PODS Relational 4. That was, I think, the all-star version, right? There's a lot of people that are on there, and with moving to pod, it looks like Pod Spatial is the second highest. So there are quite a few of them, like you said, Sashi, that are doing kind of a mix of everything and what's good for them. And that's what's great about the PODS model, is that it's definitely versatile in that you can use it in a multitude of different ways, no matter what your operations are and what your business best practices and business goals are. So last quick poll, I promise, and then we'll get straight into the demo here. How are you currently migrating your data to PODS or your current data model? So one of the following would be manually using an FME workbench, using some custom software, or maybe you're currently evaluating some different solutions and software. So promise last poll, please give us your answers here. And that way we can talk specifically to our audience that we have that have joined us today. So, all right, Susan, what about you? I'm going to give you a chance to guess what people are going to vote on here.
I would say probably either manually. First would be manually, second would be custom software.
All right, okay. Well, we are over 50% of the attendees that have voted, so I'll close the poll and share those results. And oh my God, Petrabytes, you guys, how excited are y'all that people are currently evaluating software and solutions?
Yep.
Nice.
I think there's a lot of scope, right? As I said, like it's so much variety of data in the pipeline industry. There's no one software. I think what we are trying to present today is a mechanism of how you can leverage PODS.
Yeah, for sure. So, okay, Sashi, I'm going to make you the presenter now, and that's great that everybody's here because they want to learn more, right, about what's out there. So with that, I'll make you the presenter, Sashi. And Susan, if you can give us a little bit of background on Petrabytes.
Sure. Well, I just want to thank everybody for being here. And it's exciting because we're at a point where there are a lot of changes in the pipeline industry, lots of changes in regulations with PHMSA and also with EPA methane compliance issues. So that I think that the fact that Petrabytes has a lot of experience in a wide array, including pipelines, is super exciting. So just to recap, so Petrabytes is in Houston, and the scope is upstream, midstream, and clean energy analytics using cloud and edge computing platforms. And it's really exciting to say that there are 3 US patents and 2 patents pending. And one of the flagship is Asset Duo. It's a data analytics cloud platform that has digital twin capabilities. And you'll find out what that means to pipelines shortly. And then there are engineering solutions for net zero, carbon reduction. As you know, that's going to be more important for all of you out there because you're going to have to be able to quantify the ways that you are reducing your carbon footprint in order for your company to be compliant to new SEC guidelines. And then Petrabytes partners with companies in the USA, India, Malaysia, Oman, and Canada, and then numerous technology partners, which you'll see on the next slide. So we have technology partners with AWS, Microsoft Azure, Databricks, and Snowflake. Those are cloud partners. And then there are analytics partners that you'll see that a lot of the operators love. So it's Repsol, Reservoir Link, and Shell. And then there are edge analytics, which are going to be incredibly important in the future as more sensors are out there in the pipelines. And to have them continuously transmitting data would quickly lead to ghastly costs and also intermittent outages as the data flow overwhelms the system. So edge becomes more important. So those are Red Hat, Dynamic, and Aviva. So let's take a look now at the different energy domains. So obviously we're thinking about midstream here, but the thing is that it doesn't work if you don't actually integrate in with upstream, and because sometimes the as you know, especially the GIS specialists know that the geography and the orientation of your pipelines has to do with your gas gathering systems and your units. Then there's also geothermal, refineries, petrochemical, the electric grid, wind, solar, industrial automation. All of these are interconnecting because we do see like solar applications on the leasehold. We see wind pulling into the grid. So it's just a powerful, flexible solution array for energy. So next slide, please. So I'm going to take a little bit more time and talk about some of the challenges and some of the opportunities that you have to overcome some of the challenges that you may be facing. So now as you're looking at pipeline integrity, one of the core problems is that it's very difficult to detect exactly where the leak is occurring. It's also hard to quantify how big the leak is. And then also it's very difficult to predict, have any kind of predictive ability for either predictive maintenance or at least where to locate additional sensors. And those challenges can be overcome through analytics. Also, let's think about the risk models. So if we think about inspection data and anomalies from ILI tools, some of the challenges and limitations are in the fact that tools are run over several months, changes can happen, risk analysis through combined threats still evolving. And then, as you all know too, the pipeline hydraulics are complex. We're talking about gas and liquids, very challenging, and that not being able to predict or understand what the flow rates are within or the pressures, etc., can add to increased risk. Gas prediction models cannot be applied to liquid pipelines. And then here's one of the bigger issues is the growing amount of SCADA data is continuously growing as more sensors are applied, and the integrated analysis of SCADA and risk modeling still remains a challenge. And part of that has to do with the data itself, the idea of having to do data integrity and data harmonizing, data cleansing. All those things need to be done in order to be effective. And sometimes those are not necessarily taken into consideration. And that challenge is just exactly what Petrabytes is addressing. And then also just real-time data analysis is limited. So some of the solutions include implementing standards, existing standards, new standards, leveraging cloud and edge computing. And then, as we say, liberating data has become a massive value driver in the organization. So once you can liberate data and find platforms that allow the dissemination and utilization of the data throughout the organization, you have so many opportunities. And so what data liberation does is it essentially drives your business intelligence and decision-making abilities. Anyway, that's where the solutions are going. So I think right now I'll turn it over to Sashi and he can talk about Asset Duo.
Yeah, thank you, Susan. So the purpose of Asset Duo is we wanted to create a platform where you can take all the different kinds of data, the asset hierarchy, the data sets, the measurements that you're gathering from ILI and also EMAT tools, and also all the operational information, the incidents, all of that needs to be gathered. And also when you're getting real-time SCADA systems. So the goal was to gather all of this into an integrated data management solution, and then ability to predict based on the time series data for potential leaks, and also for any kind of real-time alerts. So this is an entirely cloud-based solution. So what I'm going to show you is how Asset Geo is deployed in the cloud. So here is an example where the PODS model is actually in Azure SQL. And then we have all the models that are connected to the Azure SQL. So here is an example of the PODS model. So essentially in Asset Geo, we have like 5 different areas of how you analyze the data. So first is we do data source analysis, which we look at all the ILI data. For example, where is the data? Are you looking at your GIS databases and all of that? So we do a complete source data analysis using the Asset Geo platform. And then as we are tracking through each of these data sources with the ingestion pipelines, we'll be able to move from on-prem data to the cloud. So the idea of the cloud-based approach is to be able to aggregate and provide that contextual analysis throughout the enterprise. So we take all the data sets into the cloud and then process the data and then ultimately aggregate in the PODS model. And then we'll show you a little bit on how we can do a metadata search on the PODS data model. And then while the data is being aggregated into the cloud, we have a complete data lineage track where we can say what happened to the data, who actually gave us the data. For example, if you take companies like Kinder Morgan or Enbridge, they are working with hundreds of vendors. So they might be wanting to keep track of the entire data set. So that's what the data lineage is. Who captured the data, who approved the data, who QC'd it, and all of that. And then we have a data governance portal where we can manage all this information, like with the access control and all the permissions. And then a visualization where we can look at the PODS model with all the GIS and all of that. And in all of these, because the data is continuously growing, we have an option to actually manage all your cost as you're processing the information here. One note about the data governance is the goal of PODS is basically to standardize data exchange between systems, so that if one operator is trying to manage the information, they will use the PODS model. And if you want to exchange it with a vendor or any other pipeline company, you will use a standardized approach, right? So then with the data governance, if you really implement the PODS, you can now do a row-level security and control the access. So that's why we are strongly advocating to move the data from on-prem to the cloud. And when we do it to cloud, implement the PODS model. So today I'm going to show you the PODS 7 model, how we have integrated and how you can do the search. So this is an example of a metadata search, how you can search on the entire PODS model. And it will also show you, this is a very easy search where you can type in what is the column and it will give you the entire information. So essentially what we have done is we have taken the SQL dictionary that was created by PODS team, thanks to all the people who have really put together. So we have taken that, I don't know, it was 300-page document, we have vectorized it and we have made it into the cloud so that you can now do an easy search. And this tool will be available for everyone to try it out and test it out. The goal is, as PODS standards evolve, you will have an easy way to do the comparison and say, if I want to migrate from 4.0 to 7.0, what are the other additional things that I need to do? Like, what are the dependencies that I need to handle? So those are the kind of things we can take care of using the PODS model, using this search. So the goal is to give you a quick understanding of what all the tables are, where the search is, what are the dependencies, and help you in the migration. And as the data dictionary is being updated, we also update the description here. So for example, if you have 7.03, we are actually working on that. So in the next version, you'll also see 7.03 version. So you'll be able to search through any of the different versions of PODS. So now going back to the ingestion approach. So I know most of the companies are probably doing some custom approach and all of that, but at least as of now, you have all the inspection files using FMA Workbench and you're ingesting data into PODS. So what we have done is a new approach using the Spark pipeline. So to understand what is Spark, so Spark is a way to have distributed computing enabled in your environment. And the other good thing is it is now distributed computing in the cloud. So that means if you have, say, 5,000 files of Rosen, like ILI data, and 5,000 files of EMAT, you can run in parallel on multiple clusters and ingest the data. And imagine like if you're getting continuously the data, so the Spark will enable you to manage all that information here. So here is an example workflow in Azure, how we have implemented here. So this is your on-prem data that you're gathering from all your networks and all of that. So using Azure Data Factory, we can push the data to the blob. In this case, it's basically Azure Gen 2 location. And then here you get all the raw ILI data. So essentially, these are all the files that are aggregated. And then we have a whole bunch of Spark code. Spark, essentially, it's a PySpark code. You have a SQL-based approach. You have a Scala-based approach. So using that, we will be able to, so the asset geo framework, which I will show you, it can invoke those jobs and then populate into the pods. So this is a very simple example of ILI ingestion workflow. So behind the scenes, you have the pods model. But same thing, if you have EMAT data, if you have GIS data, if you have centerline data, all of those things can be actually run as parallel jobs in the cloud. And then we have actually asset geo runs on both Azure and AWS. So this is how the data ingestion pipelines are laid out. So let me open the software.
So while Sashi is logging in, I'll remind everybody that if you have questions, you can type those into the questions box or the chat box. And if we don't get a chance to get to all the questions today, we'll definitely do a follow-up, right? And Sashi will be available to answer any of the questions that you have.
Yeah, and also we are conducting a workshop, like a free workshop on December 15th. So anybody can sign up to go through the PODS model and also the ingestion tools. You know, so.
Yeah, and that's in Sugar Land, right? Here outside of Houston. All right, we'll get some information to everybody about that as well, Sashi, so they can join you guys.
Yeah, and it'll also be, we'll talk more about that. So if you look at the PODS model here, so essentially you have all the tables here. Like for example, you can look at the ILI, or if I say, what is my code? I can just search by code here. And then it pulls up all the tables that have this information, the code status. So this will help in quickly mapping what you have existing to the definition in pods. So the idea is we can give you a very simple search by table, by column, and then we are also adding natural language search. So you can say what is an activity model and things like that. So you can get this kind of an easy search. So the idea is the entire SQL dictionary that was put together is now vectorized and put it in the cloud so that anybody can search. So this will be available for free. Anybody can log in and then search for the models. So our goal is, as PODS is evolving, so we will be adding these models into the cloud. So you'll be able to select. Right now, this is what you're seeing is 7.02 version. But we also are now adding 7.03. So you'll be able to search all the differences, and you can also show the dependencies between tables so that you know what are all the different connectivities between the tables and things like that. So you have the entire dictionary now vectorized into the cloud, and you can take a look at all these different data sets like that. Okay? And then you can look at individual tables and look at all the data sets and things like that here. So the next thing what we do, as I mentioned, going back to my presentation, is ability to run Spark jobs in parallel. So these are, so I'll just show you an example of how you can run an ILI ingestion tool. So these are the data ingestion pipelines. So these are actually Spark jobs. So for example, if you click on ILI inspection, So these are the tools. So essentially what you're seeing here is, as I mentioned, this is running on a distributed cluster. So for example, if you click on edit job, so it shows it's the inline inspection job. It's running on this, and it's running on on one of these Spark clusters. So that is how we can run the ILI jobs. For example, if you have incidents or EMAT data or any of the facility data, all of those can be run as specific jobs, and you can run it here. So all you have to do is just run, like here is an example of how I ran the ingestion here, just for the one dummy file. And that is how you can just run this job here. So you can trigger these jobs. So what you're seeing here is behind the scenes, it is actually running on a cluster here. So this is the Spark cluster. So essentially it is running on a distributed compute environment. So just to quickly explain what is the distributed computing in this case, let us say you go to a movie theater, you have 1 counter versus 5 counters. So if you have 5 counters, you can process it faster. So this will enable you to now process data much faster. So here is an example of a compute. So now you can see all the jobs that are running here. For example, let me see. So here is an example that the ILI inspection tool is now running. So you can monitor all these jobs like that. So essentially what we wanted to present here is the ability to use Spark for distributed computing, so that you can now ingest data at scale, and then you can automate this whole data ingestion process into pods. We feel that is most important because as you are implementing the new models, the scalability becomes important. So we are actually presenting this approach here. Okay. So again, I think what you can do is you can see all the jobs, you can schedule the jobs of the ingestion and going through all of that. So we have a much more detailed session coming up, looking at the attributes and all of that. So today we just wanted to give you a preview of how this whole system works and how the Spark system works, but we'll go in much more detail about the validation and all of those things. Okay. And the beauty with the Spark architecture is if you are an AWS shop or in a Google shop, then you can take the same code and migrate it into the AWS cloud as well. So we have seen instances where we actively work with AWS and Azure, and we are able to port the same code. So right now we have PODS model running in both AWS and in Azure, and then we help companies in the migration services. So this is an example of how you can visualize the data. So previously what we were doing is we had our own storage. Right now all these pipeline assets, like all these different attributes, like the polylines, all of that, we actually used our own cloud data warehouse. Now we are using the PODS model. So essentially you can now contextualize all this information and plotting it. You can use, so within the asset geo, you can now load the data. Once it's loaded, you can now look at all this different information. One of the things we are actively working on is the sensing, where we are looking at, especially for high intensity areas, like where there's a lot of human population. We are working with a couple of Canadian companies where they actually provide the fiber. So fiber is like a distributed sensing. So in this case, what you have is you are looking for both temperature and sound pulse. So this is a fiber optic interrogator, and then we can get the data here. So you get data every meter. So why is this important, right? Apart from the inline inspection tools where you have like a mile level probability of failure, now if you combine it with the fiber optic sensing or any kind of sensors, you will get a much more meter level leak detection, so much more accurate leak detection. So here is an example of an acoustic pulse where you can see if somebody is digging closer to your pipeline, we will be able to detect the signal, and then you can get to about 10 meter, close to 10 meter accuracy. Now, this is an augmentation. This is not a replacement. This is an augmentation for your existing ILI inspection tools and the probability of failure and all the existing leak detection techniques. Okay. And the beauty with this one is both applicable for both gas and liquid pipelines. So at a very high level, within the asset geo, what we are looking at the pipeline attributes and measurements. We are looking at the anomaly inspections. Again, based on that, we have alarms and notification. And then what we are providing is the real-time calculations and also the probabilistic risk models. So the real-time monitoring is coming from these sensing equipment. So we can take the SCADA data as well as the fiber optic data. So typically, because of the expense of the equipment, they are typically installed on mainly urban areas or where there's high risk of fatality. So that is where it's being installed because they want continuous monitoring. But that combined with SCADA data, combined with overall ILI thing, and that's what AssetGeo is trying to look at. Okay, so in the workshop that is coming up in December, we have a complete detailed workflow end-to-end with all the different data sets. And as I said, like we are using the edge and cloud computing for the sensing, which we'll go through in more detail. So the reason why we partnered with Red Hat is essentially like if you're looking at a tank monitoring or any of the remote site monitoring, you'll now be able to connect the data that can stream and also capture in the Spark in the cloud. So that is another reason why you should be using Spark also, because Spark has the ability to, all the Spark code, you have the ability to listen to different protocols that are used for edge to cloud computing. So if you want to transmit a measurement of a pressure or a temperature from an edge device, you'll be able to now use Spark to capture that. But that will also help in capturing all that information along with your pipeline hierarchy. So one of the things we have been working with Aviva, which is essentially OSFI. So Aviva is good in terms of capturing all the time series measurements, whether you are looking at a pipeline, like all the assets, or if you're looking at a refinery. So they capture essentially entire time series data, right? So what we are trying to do is anything to do with real-time monitoring of the pipelines, whether it's a networking log, all of that is being ingested into Aviva Data Hub for further analysis. So this is a higher level workflow, which we'll go through in the workshop that is coming up. But just to give you an overview, you have all the facilities, you have the sensor data and the SCADA data, and that's where the edge comes into play. So what we are doing is, as I showed you all the different Spark pipelines, we have the pipeline asset topology and also the ILI data and facility data, and that can be processed in the cloud. And then you have the analytics and the physics models. What our eventual intention is, we are also capturing incidents from EIA. That's also being captured. So we are thinking of, enabling operators or the pipeline operators to have one single tool where, if you want to say, give me a weekly report, sorry, a monthly report that you are obligated to FEMSA, from the software itself, you'll be able to export all the incident reports and give it for compliance. So if you really work through the entire architecture, it'll be easy to, and use PODS as the primary data storage, then you have the ability to quickly give you that reports instead of manually creating Excel sheets and so on, right? So I think the purpose of this presentation was we wanted to show how you can leverage Spark or the cloud-based approach and the PODS to have large-scale data ingestion and also the compliance. So extending to the fiber optic sensing that we are actively working on with a couple of pipeline companies is, the idea is the distributed temperature sensing and acoustic sensing will listen for sound along the pipelines. And there is also vibration sensing and also the strain sensing, especially when you are looking at third-party damage, when you're looking at the hazards and all of that. These are, especially in those areas, these sensing equipment is being introduced. So we are processing all of that information here. So essentially what you're actually measuring is any deviation, just like you're looking for dents and all of that in the ILI data. Here you're actually monitoring the pipelines in real time, where you are looking at any kind of strain movement or any kind of temperature drop. Let us say there is a drop in temperature, that means there is a leak and things like that, okay? And then you also have the acoustic sensing, which is looking for sound. So anything activity that is happening here, you can monitor in real time. So this needs to be combined with the ILI risk modeling that typically people do, because that is more like a static model. It's not like dynamic until you again rerun, right? But combining that, let us say on an ILI model, you have identified there is a potential risk of failure on a particular pipeline, then you would go into the SCADA systems or this kind of sensing to look for more accurate monitoring on a timely basis. So this is more like a real-time monitoring. And another important reason why we need the Spark-based approach is the data that is being generated in some of these things is gigabyte scale per day. So it's a lot of data. So you need to analyze that information. Okay. I will just quickly show you the asset geo once, how it looks like. So this is an example of how we are actually we are doing a POC with a pipeline company. So what you're seeing here is a pipeline here. Here is the acoustic sensing pulse. So here you have the length of the pipeline with this class A, class B, class C. And at this time T, you have this acoustic pulse. So what we are doing is, as we are navigating through each one, the pulse is changing. So here is where you see the activity that is happening. So this is like real-time monitoring of your pipeline, especially the high-risk pipeline, with across the class, and that is where you will quantify with your, again, back to your PODS model. So this is giving you a statistical threshold, so you can alert the user that something is happening here. So when it comes to incident reporting, right, most of the time there is a lapse before there is a response, but at least here you will be able to exactly pinpoint, if not to the exact meter, but at least within the range of 10 meters where the potential risk is going to happen. Now, if you're somewhere in the rural area, maybe you have more time to respond, but if you're in the urban area, there is a leak or something happening, that is where you'll be able to quickly identify this potential leak with this, because it tell you what is the time and also at what is the length of the pipeline where this potential leak is happening. Same thing with the temperature profile. Here, when there is a drop, you say there is a potential leak because there is a drop in temperature. It could be a gas leak or it could be a water leak. So that is how you'll be able to exactly pinpoint where exactly, at what time and at what length of the pipeline you have a potential leak. Okay? So this is an approach where we are thinking like you combine your statistical, Monte Carlo simulation-based ILI analysis risk models, combining with real-time monitoring of your strategic asset of your pipeline, and that is how you are basically mitigating your risk of failure, either quick response to your leak detection and so on. Okay, I'll just quickly present you the predictive workflow methodology that we have developed in AssetGeo. So essentially, we are looking at all the asset. This is the data gathering step, and we have the abnormal event detection, where you have the alerts, the event log and notification and measurements, and the time. And then we also have the reports and integrated data analysis. So in this case, as you're getting the signatures from this graph, like for example here, let me show you this. So you'll be able to get a much more features in each of these. So we can identify these patterns, and based on machine learning, we can do which assets are really affecting basically identify the outliers of your events, and from there we will be able to identify where the leak happened, when it happened, and those patterns are basically captured. So next time when there is an event, we can capture it with the existing pattern registry. Okay, so that is how we are trying to augment. So now when it comes to the pod model, you might be wondering, how are we actually storing this information? We have a custom schema for the SCADA systems and also for the sensing data. So that is something we want to contribute and work with you, because we have already analyzed this data mainly to bring in the real-time component for the pod system, for the pods data model. Okay. And here is an example of how we can predict an event. So essentially, this is a statistical threshold. So this is like a warm back. So for example, there is a leak, and then there is again it's building up. So you can detect these kind of statistical thresholds. So that is one example of how we are able to detect all this. Okay. Again, we have covered a lot of things, but we are having a workshop on December 15th. It's free. The goal is to go through these, whatever we have presented today, in much more detail with a lot of sample data, and then run through the pipeline. So run through the data pipelines and look at the PODS model. So it's a 2-hour workshop. So anybody is free to join, and we'll send you more information about the sign up. Thank you.
So Sashi, thank you so much for that. That's a great presentation, a lot of information there. We do have a question from the audience, but I want to ask a question first, which is, you said the word free in there a couple of times, which is my favorite 4-letter F word. So if can you explain to us again, you know, I mean, look, I run a nonprofit, right? Everything's got to be free for me, right?
Yeah.
So what all do they get for free there? Because that's an incredible contribution. We have several of our PODS service company members that donate things for free around their technology in order to move the ball forward in innovation. So can you cover that one more time?
Yeah, so the data model search and also ability to contextualize doing a natural language search and get all that information. It's currently running in the AWS cloud. So we are partners with AWS. So we were thinking like just like every other company, we also faced challenges as we were migrating. So that tool of understanding the data model between different models and quickly identify all of that and the dependencies and the graphs. So that tool, we are thinking we are going to open source that. So basically people can log in and search through the model and look at the dependencies and compare between previous model and the current model. So that will help them plan the migration, like how much change it is. Is it a 3-month effort or a 2-month effort? Basically better understanding of the model, right? Because a lot of work has been done with a lot of documentation. We are providing an easy natural language search.
Well, that's huge because, you know, I know a lot of operators when they're trying to figure out what the, you know, scale, scope, and effort is for these migrations, it's difficult to do, right? One of the #1 issues that people have is trying to get, you know, qualify their data, right? Make sure that is of good quality before they put it into a new system. And so that's a huge lift. So you guys are taking care of a huge step of figuring out probably a much better idea, because you still never know what variables are going to come up anytime you do a migration or a project or whatever, but you have a much better idea of what you're working with. So you're helping the operators plan, right, a lot better for their migrations and their integrations, correct?
Yeah, and a lot of times we have seen that, you know, people have like the source and target mapping problem, like they have existing proprietary systems that everybody is using. If you migrate there, they feel there is a risk. So this will help in mapping the attributes because we have been doing that quite a bit for a lot of things.
That's great. Thank you so much for that contribution to the community. That's very helpful, and it's going to help a lot of our members. So, and it helps me because it adds extra value to being a member of PODS, which makes my job easier. So thank you very much. So we have
just one small comment. So basically during the holidays, we'll be launching that site and then anybody can sign in. So what we are right now, we have 7.02, we are adding 7.03, and you'll be able to see the differences between the models and all of that. So essentially what Jackie put together in a simplistic diagram, we are trying to make it even simpler with an easy search.
That's awesome. Yeah, so what Sashi's talking about is we're grateful that he's been volunteering for the training and education committee and helping out with a lot of the work that Jackie's doing to make our conceptual table model a little bit more readable, right, for people like me and people that want to utilize it or maybe not an extreme GIS professional. So we're going to walk through the table and give you examples of how it all works and how it goes together. So a lot of great work happening there. So thank you, Sashi, for volunteering on that committee too. We appreciate it. So and what we'll do too is because you guys don't have it on your website yet, we'll follow up with everybody that registered for this to get them in the information about the in-person demo in December, as well as the portal that you guys are going to be putting together, if that's okay.
Yeah.
Awesome. Okay, great. So we have a question. This is from an operator. Asset Duo seems to be cloud compatible, which is great, as our company is an Azure first shop. Does Asset Duo work well with MS Data Fabric? I hope you know what that means, because I don't.
Yeah. I mean, conceptually, the MS Data Fabric if you look at it, it is implemented the same way of how Databricks and Azure had their own implementation of the Spark. Right now, the code is extremely generic. So if a company decides, like for example, we have been working with Shell, they have multiple implementations of Fabric and also the Spark-based approach. So the code is actually portable. Like at some point you want to move to a different technology, so we'll be able to use the same code. So we have been able to run on both Google Cloud, AWS Cloud, and Azure as well. So.
Awesome. Thanks for that. So Susan, I'm going to kind of direct this next one to you because I know you have a background in the entire asset value chain, right? All the way from exploration and production and all the way through. So you guys mentioned integrating with 7.03 utility network. So are you guys, Susan, are your clients seeing a lot of that? Or you have some clients that have well pads and gathering lines, and sometimes unfortunately they'll say that unfortunately they have pipelines as well as well as pads, right?
I would say absolutely yes in terms of clients. Now whether or not that asset is in the same team or those different assets are in the same team, that's a different issue altogether. And I wanted to bring up one thing that's happening that's sort of creating an emergency situation in terms of data right now, and that is the merger of different pipeline companies, merger of that, and also the acquisition of assets by others. And when those deals are forged, I'm not sure that they're thinking about how they're going to actually manage and run them. And I thought maybe Sashi could address specifically how the solutions help.
Yeah, as you said, like most of the time, it's like the source to target mapping becomes a big issue when you have multiple companies having their own formats. And that's where we feel like if you implement pods, then you have a standardized way of data exchange as you migrate, right? And then what we are helping with all these tools, like AI-based search and things like that, is understand the data model and look at the effort of migration. There'll be situations where there'll be a lot of custom schemas, and that's where they can contribute, like just like how we are trying to see if we can contribute to the SCADA-based data sets as well to
well, and what's nice about that is that in doing that, you're essentially doing a quality control overview of the asset itself in the integration of the two pieces or more, depending on the situation. So you're kind of getting two benefits at the same time. You're able to update your risk evaluation and do predictive maintenance, and also pinpoint the trouble areas and prioritize, so you can avoid more costly repairs later on.
That's a great point. So, to that end, I know that the PRCI guys wanted to join today, and unfortunately they couldn't make it, but they've been asking recently whether or not if SCADA data has a home in pods. And from what I can tell, the answer to that, unfortunately, is no. But it seems like you guys are doing a lot of integration with ILI data and SCADA data and everything there. So, maybe there's an opportunity for us to add those data tables in for SCADA as well. Of course, if it makes sense for the operators to do so. Are you guys seeing that where people are trying to integrate that data?
Yeah, I think they are you are partially right, because that is a whole new system in itself. But at some point there is overlap. Like you are saying, where is this SCADA data collected on? It's on a pipeline or it's in a terminal, it's somewhere, right? So it still can be connected to the asset. So that is where you need to be able to connect, and then you can say pods real time or something like that. That could be another model where it's a completely managed by separate team. But at the end of the day, all of these are interlinked. And that's where you can do the mapping. So, yeah.
And like in terms of integrity, that's one piece of the data puzzle. But if you're thinking about efficiency of operations, et cetera, then thinking about your gas conditioning units and the gas gathering systems and the automation in that. So this can integrate into automation, automated solutions, so that you can optimize, for example, the way that you enter the way that your gas enters the pipeline, integrate the chemical conditioning for the gas conditioning, so getting rid of the nitrogen and the negative things, and then also integrating in your fugitive methane emissions data. So it does more than one thing, and it can, and in doing that and integrating it and automating, save tremendous amount of money.
That's great. And, you know, we all know that the key right now is to optimize our in-ground assets, right? We have an aging infrastructure here in the US that we need to make sure that we're optimizing, because, you know, the unpredictability of permitting is not really giving us a lot of forecasting around building new pipelines. So we need to do our level best to add and apply technology to our existing systems so that we can, like you said, Susan, save money and work more efficiently and optimize to those business goals. So that's awesome, guys. We don't currently have any other questions at this point. Is there anything y'all want to say to wrap up? We do appreciate it very much. I appreciate that you guys talked about the regulation too. I want to remind everybody we're going to have some information coming out for our next podcast in January, and that's going to be with PHMSA, and they're going to go through what they're calling year zero. So the baseline year for all of the additional attributes that you're going to need to submit for your MPMS submittal. So with that, Sashi, Susan, I really appreciate you guys spending time with us. Do you have any final thoughts for the group?
No,
I just
go ahead, Susan.
I just want to say thank you, and I'll pass it over to Sashi.
Yeah, thank you. As I said, like, we are very pleased to work with the PODS team, and as I said, like, we are trying to help in whatever ways we can based on our learning. And there is so much. I think the more we implement PODS, the easier the software becomes in terms of managing information.
That's awesome. Well, thank you again so much. We really appreciate Petrabytes for sponsoring this podcast. If we go to the next slide, you'll see Susan and Sashi's contact information there, and we're going to send a follow-up email as well. Don't forget to give us some feedback on the survey you're going to get as soon as we close out of this podcast. So thanks, everybody. I hope everybody has a great end of the year. Happy holidays to everyone. And thank you again so much for an incredible 25th year anniversary of PODS. So with that, we'll sign off. Thank you so much.
Thank you. Thank you for the opportunity. Thanks.